Chapter 12-4, angle measures and segment lengths. All right, so for this video, I will just be doing the segment lengths part of this chapter. All right, in the first case here, we have two chords. See the two chords inside the circle? And we're going to do A times B, and that's going to equal C times D. All right, and that's what they wrote. A times B equals C times D. So you just take the two pieces or segments of the chord, multiply each one, and set them equal to each other. All right, so that is case number 1. All right, so in case number 1, the products of the chord segments are equal. Case number 2 is when you have two secants, all right, two secant segments. And what you're going to do is take the external segment, which is W, and multiply that by the entire segment here, which is going to be X plus W. Okay, so the external segment is W, and that's going to be times the whole thing here, which is X plus W. All right, so that's what they did right here. And then on the other secant, it's the same thing. The external segment, let me erase this, what I wrote so far. The external segment here is just Y, and the entire segment here, if you take that whole thing, that's going to be Y plus Z. Okay, if you added both of these segments, that's going to be Y plus Z. So it's the external times the entire segment of Y plus Z. So in case number 2, the products of the secants and their outer segments are equal. Case number 3, a tangent and a secant. So for the tangent segment right here, you take the tangent segment T and you multiply it by itself. So that's just T times T, which is T squared. Okay, and that's right there. And then for the secant, it is just like case number 2. It's going to be the external, which is Y, times the entire thing, which is going to be Z plus Y. Okay, or Y plus Z, same thing. So the tangent, you just multiply it by itself, T times T, you get T squared. For the secant, you do the external, which is Y, times the whole thing, which is Z plus Y, or Y plus Z. All right, so in case 3, the product of a secant and its outer segment equals the square of the tangent. All right, problem 3, find the value of the variable in circle N. Let's take a look. All right, so right here you can see that we have two secants. So for the secants, remember, you want to do the external and that's going to be times the entire secant. All right, so we're going to multiply the external and then we're going to multiply it times the entire secant. All right, and set them equal to each other. So what would that look like? Well, the one on the bottom here, the external segment, is this right here. That's just 7. All right, and that's times the entire secant. If we did the entire secant here, we have 7 plus y. All right, so that whole thing is 7 plus y. And that equals the same thing on the other secant. The external is 6. And that's going to be times the whole thing, which is 6 plus 8. All right, distributing. 7 times 7 is 49. 7 times positive y is positive 7y. 6 plus 8 is 14. All right, and 6 times 14, that's 84. All right, solving for y, the opposite of positive 49 is negative 49. Cancels here. Bring down your 7y. Let's see, 14 minus 9 is 5. 7 minus 4 is 3. Here we have y times 7. The opposite of times 7 is divided by 7. The 7's cancel. And y equals 5. All right, part B, we have a tangent right here. And we have a secant right here. So for the tangent, you want to do the tangent squared. And that's going to equal the external segment times the entire secant. All right, so let's see. For the tangent squared, the tangent length is z. So we're going to start with z times z, or z squared. That's going to equal, on the secant, the external segment, which is 8, times the entire secant, which is going to be 8 plus 16. All right, of course, 8 plus 16 is 24, and if we do 8 times 24, that's going to be 192. And that equals z squared. All right, in order to undo this z squared, you want to take the square root on both sides. So square root of z squared is z. Square root of 192, I'm going to round off, okay? So I'm going to put these squiggly lines here. That means I'm going to round off. Let's do the square root of 192. All right, square root of 192. It equals, and 13.85. Since the second decimal is 5 or more, we're going to round it up. That's going to be a 13.9. All right, so z is 13.9. I use the squiggly lines because I rounded off. All right, got it. Problem 3a and b. You want to find the variable and round to the nearest tenth. That's 1 decimal. So let's do them one at a time, starting with a. All right, here's a. There's two secants, so do the external segment times the entire secant on both sides of the equal sign. All right, external times entire secant. All right, let's see. On this one here, the external segment is 14. And the entire segment is 20 plus 14. So it's going to be 14 times 20 plus 14. On the other secant, the external is 16. And the entire secant is x plus 16. So use parentheses because it's times x plus 16. On the left here, 20 plus 14 is 34. And I'll do 14 times 34, which is 476. On the right, distribute 16 times x. And 16 times 16, that's 256. Solving for x, the opposite of positive 256 is negative 256. It cancels on the right. Bring down your 16x and your equal sign. 6 minus 6 is 0. 7 minus 5 is 2. 4 minus 2 is 2. We have x times 16. The opposite is divided by 16. Okay, 220 divided by 16. I have 13.75. And I actually got that without rounding off. But if it says nearest tenth, then I guess you would round off to approximately 13.8. All right, but that is part A. All right, part B. We have two chords here. You just want to find the product of each. So you do 3 times 7 equals m times 6.5. Please try it. All right, this chord here is 3. And this chord here is 7. Product means you multiply. This chord here is 6.5. And this chord here is m. So it's just 6.5 times m. All right, solving for m, the opposite of times 6.5 is divided by 6.5. Cancels here on the right. 3 times 7 is 21, divided by 6.5. And I get a big decimal. If I round it off, it is approximately 3.2. So that is for the letter M.